agents. And the idea is that then if we were to inject these into a human patient, the protein shell would protect those molecules from interfering with where the capsids go, and it would protect them from being degraded on the way. Secondly, then, if we have another set of chemical modifications on the outside of these spherical shells, these could then install targeting groups. These would be binders that would bind these to specific types of cellular targets. They would then direct them to things such as tumors, solid tumors, thus focusing the cargo just on that area, which would be beneficial both for imaging, if you wanted to diagnose the tumor tissue, but also for drug treatment as well. And so that was our goal for developing some of these new chemistries, because again, we need two different places to modify this, one on the inside, one on the outside. One other sort of feature about MS2 capsids, and really the reason we chose this virus over the huge number of other ones that we could have, is you can see these dark spots in the capsid shell. These are actually holes in the surface. These are about 2 nanometers wide, and for comparison, this is the molecule Taxol, which is one of the more complex drug molecules that's used to treat breast and ovarian cancer. And so this molecule, you can see, fits quite nicely in these holes, and that means that the molecules could drift inside the capsid shell, and then we could do covalent chemistry to attach them to the inside surface. And in that way, we wouldn't actually have to tear it apart and put it back together again. And so that was the earliest chemistry we developed. These are 2 ways to do it. I'll just summarize this briefly, that you're looking at the inside of the capsid shell. In green, I'm showing a tyrosine residue here. There are 180 copies of that on the inside of each of these spherical capsid shells, and we can modify this using, this is that diazonium chemistry reaction, and this would introduce this X group here, which would be your cargo of interest. And we've developed that chemistry over the years. The other one is, as I mentioned, cysteine chemistry. We made a genetic mutant of MS2 with 180 cysteines on the inside, shown as red, and now we can use these